Hello everyone and welcome. Today we are going to try to look for reduction formulas for the integral of x to the n sine of mx dx. Well, we can also try to look for reduction formula for the integral of x to the n cosine of mx dx. But the approach are very similar, and this will be a good exercise for the students. Now, to do this, typically, like I said in the previous video, reduction formula typically involve reducing the powers of the exponent here. So that, for example, now we can try to connect the integral of x to the 5 of sine of maybe say 7x dx. What reduce it to something like the integral of x cubed of sine of 7x dx. And then we can now reduce this to something like the integral of x to the sine of 7x dx, whereby this one is easier and simpler to compute than this and this. So reduction formula is a formula that allows us to reduce the powers of the exponent that appears in the integration. Now let's say we want to work on the integral of x to the n sine of mx dx. Now as well, we're using the integration by parts, which says that the integral of u dv is equals to uv minus the integral of v du. So here we're going to write this as, now the integral of sine ms is negative cos mx over m. So we're going to have negative x to the n cosine of mx all divided by m. Now we're going to have plus the integral of, now we have a, first of all, have our n over m here, so that would be x to the n minus 1 times the cosine of mx dx. Now we are going to try to also find out this integral here, this one here. So let's say the integral of x to the n minus 1 cosine of mx dx. So this would be again the integral of cosine of mx is sine of mx over m. So we have x to the n minus 1 sine of mx all divided by m minus, now we would have n minus 1, so you have n minus 1 all divided by m times the integral of x to the n minus 2 sine of mx. Now you see what is happening here. You can see that we started off with integral of x to the n. Now we having something of x to the n minus 2. So that should tell you that at least our formula is almost complete. So let's see. The next thing, now we have that the integral of x to the n, sine of mx, dx. This is equals to, now we have negative x to the n cosine of mx all divided by m plus n over m times, now we need to put down this value, which is x to the n minus 1 sine of mx all divided by m minus n minus 1 over m times the integral of x to the n minus 2 sine of mx dx. So that would be equal to negative x to the n all divided by m cosine of mx plus n over m squared x to the n plus n x to the n minus 1 over m squared sine of nx minus n minus 1 over m squared times the over m squared times the integral of x to the n minus 2 sine of mx. So you see what is happening here now, dx. So we're able to connect x to the n to x to the n minus 2. So now that tells you that, okay, let's try this formula down here over here. So we have, wait, let me see if we can maybe copy Hold on, let's see. Can I able to copy this? Nope, I cannot. So let me just take out the top first. Just hold on. So I'm trying to create a space at the top so we can write something there. Okay, now let me change colors. Okay, hold on. Okay. Now what we have here is that the integral of x to the n sin of mx dx is equals to the whole of this. Now suppose we now have to integrate x to the third, let's say x to the third sine of 7x per se. Suppose this is what we'll have. So if you plug this into the formula here, this is the case whereby n equals 3 and m is equals to 7. So we have negative s to the third all divided by 7 times what? The cosine of 7x plus now 3x squared all divided by 49 times what? The sine of 7x minus the integral of x. Okay, no, minus 3 times 2, that is 6 over, because this is n is 3 times 2, that is 6 over 49, that is minus 6 over 49 times the integral of x. 3 minus 2 is 1, so that would be sine of mx dx. So you see that this much more complicated integral has been reduced to this simpler integral, whereby easily we can find the integral of x sine of mx as follows dx. So we can do this as we don't even need to use the formula. We can use the formula here though if we set n equals -1, because we're going to end up with a integral that has sine x all over x squared, and this is not something you want to do. So that we can do this directly and write this as a negative x cosine of mx over m, plus the integral of cosine of 1 over m cosine of mx dx. So that would be negative x cosine of mx over m plus sine of mx over m square. So you see that we are able to complete the integration. So this integral, we reduce it to this integral, and this one we have integrated it completely and got this answer. So you see that if we combine it, we have already gotten the result for this. And also same thing applies. Suppose you have the integral of x to the 4 of sine of 7x dx, or the integral of x to the 10 even of sine of maybe 9x 10x dx. We can, all we need to do is to apply this formula step by step, and we'll break the powers down. It depends on the parity of m. If you have an even, we're going to connect this to something of the integral of sine of 7x, because if you keep subtracting 2 from even power, and eventually you will get to x to the 0. So this will be easiest to compute. But if n is odd, let's say this is 11, you will be able to reduce it to the integral of x times sine of 10x, and this one is not too hard to compute as well. So you see that we have demonstrated that it is possible to integrate sine of nx, the x to the n sine of nx dx completely, and this is the result of the reduction formula that we derive. So thank you for watching, and please do subscribe to the channel. Bye and have a nice day.